Welcome to Nap Science. I'm your host, Near Diskin. Woo! Today we will be talking about a major part of all physics problems, motion diagrams.
What is a motion diagram?
Thank you for asking, respected caller. A motion diagram is a composite photo showing an object's position at equally spaced several instances of time. It's like a movie reel, but still relevant. Whew! Motion diagrams are used throughout physics to understand motion and interpret information at important points. What's an important point, you may ask? Good question. According to this here document, important points are places where the type of motion changes from one form to another. For example, a ball rolls along the floor until it's stopped by a wall. Right where it stops is an important point because the type of motion changes from a constant motion to a motion with a huge negative acceleration. At this point, things like velocity and acceleration change. Velocity is the speed of an object with direction, and acceleration is the force upon an object causing it to slow down or speed up. This means that velocity and acceleration are related, as will be evident in the motion diagrams we create. Now, let's look at an example.
The first thing we need to do to create a motion diagram is to create a simple picture. After you draw this picture, identify important points where the motion changes. In this example, this occurs when the ball begins rolling, the ball is kicked, and finally when the ball hits the ceiling. The ball initially travels at a constant speed towards the kicker. This means that there is no acceleration and velocity is always constant. Given this information, you can make all of the dots equal distance apart and draw the velocity vectors between each point, labeling them as you go. For the second part of this motion diagram, we see projectile motion. The ball initially starts fast and becomes slower as it travels towards the ceiling. This means the dots on our diagram will become closer together as they approach the ceiling. After you draw the velocity vectors, we are going to need acceleration vectors. Acceleration vectors are found by subtracting the second velocity vector from the first. Put these vectors next to the velocity vectors, and then draw the final section of motion between the ceiling and the floor.
Well, that concludes our study on motion diagrams, folks. And remember,